So I will start now. Hello, welcome everybody. My name is Joseph Stephen. I'm a cloud solution architect in data and AI at Microsoft. And essentially what that means is I help customers and partners alike working through use cases, optimizing their platform, and just overall working on their architectures for areas like efficiency, performance, and just to overall modernize what they already have. So that's myself, and today, I'll be doing essentially a deep dive on Azure OpenAI service, doing essentially just a presentation on what OpenAI is about. The concepts and the foundation. So that will be around half an hour, and then I will do a demonstration for about 25 minutes where I'll demo a few awesome use cases and a bit of the code and how you'll go about engineering with OpenAI, what prompts are all about, and how you can improve your prompts to improve the responses. And then I'll open up to any questions in the audience. So, starting with a bit of brief history of AI and machine learning, it was about 1956 where artificial intelligence, started to surface and come about, and that really is the umbrella sort of concept of the idea of applying machine learning and machine data to create new intelligence, new data, to generate new data. And then about 40 years later came machine learning. So really a subset of what it means to be artificially intelligent that specifically relates to learning over a corpus of data, a history of data in order to make a prediction of sorts. So it's really concerned with what's next and the idea of trying to make a prediction. Then, with further research, about 20 years later came the idea of deep learning. So now we took what we have in machine learning, learning historical data, and we're now creating these neural networks to imitate connections in the human brain. So, those comes in forms of multiple parameters and layers that form a neural network in order to make connections between different paths and decisions. And then we come to now where we have this generative AI. So we've taken everything that we've done in machine learning and AI, the idea of trying to make a prediction, the idea of learning on historical data, and this is now focused on generating new content. So generating content that the model hasn't seen before. It's not trying to no longer make a simple prediction where it's saying, okay, given these past events, this is what I predict the next event to be. It's synthesizing. It's taking the data and it's generating new unseen data. So that's where we're at now. We're at this awesome period of generative AI. So I'm sure you would have seen in the news and everything, of ChatGPT. I'm sure you would have used it in some way, shape, or form. The AI technology is here, as you would have seen. It's very popular that people are using it to assist their current, operations and tasks and just their day-to-day lives. So, as I said before, it's all about content creation. A few example prompts. So these are queries that you ask a model are something like, write a tagline for an ice cream shop, and that will generate new content. So in this example, we serve up smiles with every scoop. That is new unseen content. I'm having trouble turning. I'm having trouble getting my Xbox to turn on. The response is, there are a few things you can try to troubleshoot this issue. Da 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 da. So the prompt is now saying, what games do you recommend for my 14-year-old? So the idea of having also this chat experience, because we're now applying, the idea of synthesizing new data. Why not chat with it? So having this whole chat experience. So as you would have seen in ChatGPT. The third example here is using ChatGPT or just the content creation GPT models to generate some SQL. So it's giving the model a table, and it's saying to create an SQL query for all customers in Texas named Jane. and the GPT model will respond back with some working SQL. And finally, using the prompts to generate images. So a ball of fire with vibrant colors, and the response is an image which relates to the prompt. So Azure OpenAI Service does come with a few of these models for these specific scenarios. Some of them can be combined and grouped into generative text models, so models that specifically relate to generating text, and those are namely GPT 3.5, GPT 4, and ChatGPT. There is also the Codex model, which is in red and strike through because it is now deprecated, but the model itself is now infused in the GPT model. So the idea of being able to generate code lives within the Codex model. So we saw before, trying to generate the SQL query, that's invoking the Codex model, which now lives under the GPT models. And then the DALL-E2 model, which is specifically concerned with generating images. So it's multi like model in that sense. So this is our Azure AI platform, and so just for context, this is where Azure OpenAI Service sits. So right in our customizable AI models, we do have a lot of other models such as speech, language, vision. So doing things like speech to text or text to speech, or computer vision, so counting the amount of people or like faces within a certain frame. And then sort of we have our other applied AI services, which is more of a specific subset of models that we've already trained. So things like form recognizer, the ability to extract key terms and sections from a wide variety of forms. For example, invoices. So if you wanted to automatically extract invoices, you might go to Form Recognizer, which hosts an invoice model to extract things from an invoice. Or similarly, you might have other forms which you might train custom like models on. Video indexer, very similar business. You give it a video, it'll extract where people have spoken in the video, the key frames in the video, the transcript of the video, a few sentimental analysis of each of the frames. So we have our applied AI services specifically geared towards specific use cases like that. So yeah, just a quick overview of Azure AI, and right at the bottom we have Azure ML there for hosting your own models and interacting with your own models. So it's our Azure machine learning platform essentially. We can now, as of recent, it actually integrates with Hugging Face models. We're going big on open source. There are lots of open source models out there, which you can now use out of the box with Azure Machine Learning. Very, very cool stuff there. Another point I wanted to quickly mention, and I won't spend too long on this because this can honestly be a topic in of itself, but this is essentially our responsible AI principles. We believe that the development and deployment of AI must be guided by the creation of an ethical framework. So some of these principles within like the framework are, privacy and security, inclusiveness, accountability, transparency, fairness, and reliability and safety. So, we have these key areas such as governance. Sort of these blocks that you see on the right hand side. We have like the governance, which in turns to rules, which turns to training and practices, which turns to tools and processes. So having these principles in action is very important to ensure that your service and solution stays within these responsible AI practices. So definitely worth mentioning. Some of these capabilities involve answering questions, classifying text, translating language, summarizing text, and I'm sure, with your interaction with ChatGPT and GPT models, there are lots you can do with it. And those are some of the use cases that we'll hopefully see later in my demonstration. Some important ones to call out that we've seen is using it to generate content, summarize content, to generate code, and semantic search. So, you might have lots and lots of data, and being able to semantically search that data is very important, and something that we'll also see in the demonstration soon. So, yeah, some examples of use cases. So end-to-end call centers, or customers, corpus of information and like data, and also business process automation, to name a few. I'll stop here before I move on to comparison. Any questions so far? Nope.
All good, I think.
All good. So I'll continue moving on. So comparison quickly, GPT 3.5. These are a few like nitty-gritties of hosting, but essentially it is really good for chat and completion. And ChatGPT is currently in preview, but it's specifically geared towards that whole chat experience. So if you wanted to, have that sort of chat experience, you'd be using something like ChatGPT. And GPT-4 is a bit more fleshed out in terms of its parameters. So I think it's trained on something like 1.2 trillion parameters. So it's a lot better at giving robust results, because it's trained just on so much more data. And we do currently host that as part of Azure OpenAI service, and it currently is in preview like ChatGPT. So just a few on Azure OpenAI service. So now we'll get into a few of the key terms and the concepts of large language models and Azure OpenAI service as a whole. So some of these key terms that we've seen is the idea of prompts. So, this prompt is saying, extract the mailing address from this email. It's a text input to a model. It is the query that supports the overall content. Secondly, we have a completion. So, we have our prompt, something that we ask the GPT model, and then we have the actual response itself. So that response is known as a completion. So essentially the output that the GPT will generate. And lastly, we have the tokens. So tokens is how we compute and translate words within the prompt to its associated data representation. So these could be partial or full words that are processed. So very simple words that we expect to see appear often in text. So just the word I will be represented as a single token, where more complex words with multiple syllables, maybe more than 2 or 3 syllables, might be broken down into multiple different tokens. And you'll see a bit more of that representation soon in the concepts. So before I start into the concepts, it's worth noting, what is a large language model? And we've seen this term LLM or large language model around everywhere, and I thought, let's just take what the definition of Wikipedia has and let's explain it that way, because I think that the definition here is actually really nice. So it is a language model consisting of a neural network. So as I said before, it is a language model. It is a model that specifically is concerned with predicting words. So it's really concerned about words and how to predict the next word. And it's built using a neural network. So having, the input layers, the hidden layers, the output layers, and having that sort of neural network available to make those connections is what really drives a large language model. And these neural networks typically have many parameters. There's no set one definition for how many parameters. So I think if I look here, though the term large language model has no formal definition, it often refers to deep learning models having a parameter count on the order of billions or more. So generally, if it has parameters in the billions or more, it's considered a large language model. And that's trained on large quantities of unlabeled text. So, it doesn't semantically know what these words or text is. It is unclassed, it is unlabeled. So how does it create that semantic? Well, it creates it in two methods of learning, which they've set here: self-supervised learning, right? So the idea of, we've learned in machine learning, we also have this, idea of supervised learning, where the class of your data, semantically what this piece of data relates to. If I'm looking at a bunch of pixels which represent a blue car, AI model, an ML model, if it's being supervised, it will know that this is a blue car and that these data parameters relate to a blue car. Self-supervised learning is not necessarily unsupervised or supervised, but it goes through a learning process of trying to map these data inputs to a class that it will just try to guess, essentially. So it's really good at looking at these sort of classes of data, and because it has so much knowledge, it's able to actually self-supervise itself and say, okay, I know what this is because I've seen so much of it. I can accurately guess what this is. Or semi-supervised learning, where essentially you might give a subset of classes, let's say on 100, like the data points, but you might have 20 billion points, right? So it's only giving like a subset of the data that you expect to be within those points, and that's what we call semi-supervised learning. So those are the two types of learnings that are really involved in large language models. So now that we know large language models, we can sort of delve into a bit of the concepts of what we've seen. So I've sort of explained this already, the idea of having a prompt and completion, right? The prompt is the query, the completion is the output. So it's a short piece of text used to initiate an AI language model to generate a longer piece of text. So in this case, you have your initial sort of like data in computer science, blah, 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 and you might want to give a prompt to summarize the previous text in like 2 sentences, and the completion is that response. So the best practice here is to be specific, is to be descriptive, ordering matters, and to double down on what you prompt to the GPT model, right? So the more you are specific, the more specific response you'll get back. If you give a very high level prompt, it will give you possibly a high level response. But if you wanted, I want it to be a bit more specific, or I didn't want the response to be as long, you might be descriptive and be specific in that manner by saying only summarize in 3 like sentences or 2 sentences, as in this example. And then we spoke about tokens before, the idea of splitting words into individual parts for the purpose of data representation. So we've seen in this example, it's a beautiful day outside might get tokenized into something like this. So we expect, it and, dash is and a, these are all individual tokens that we tokenize. And those are the equivalent data representations that the model is used to train on. And that's called an embedding, which is a good segue into the next concept. So embeddings are a representation of tokens as numerical vectors for machine learning algorithms to process. So, we have these words and we tokenize it, by, words or like syllables, depending on how you've defined your tokenizer. As the case of ChatGPT, it has a default tokenizer, which represents, I think, around approximately 4 English characters per per like token. So per token is approximately 4 characters of English text. And those embeddings essentially get translated into their appropriate numerical vectors. And so why this is important is because we adopt a method for computing the relationships between each of these embeddings. And we do that by adopting a pretty popular, I guess, mathematical function, if you will, called the cosine similarity. And so what that would do is it will essentially, that's the weighting that is applied on these embeddings. So, if we wanted to determine the similarity between 2 embeddings, a cosine similarity is computed so that the model can accurately make its next prediction. So that's how we semantically generate meaning between different embeddings. And the mathematics is quite involved, but yeah, I do encourage, if you're interested, to look on the Wikipedia of cosine similarity and the mathematics behind how the similarity between 2 embeddings is actually determined. It's a very interesting read. Next concept is hallucination. So we might have heard this concept, and it's the idea that it generates garbage responses, right? The idea that it's a confident response that does not seem to be justified by the model's training data. So it gives you a response that is just nonsensical and what we might call a bit too creative. And there are ways that you can adjust this, and I'll get to that soon. But in this example, we're saying, give me the address of Microsoft Office of 5th floor in NX Perth, and it'll give that. But if you say, if I add say, I don't know, if you don't know this information, this is one way that you can actually reduce those hallucinations, is by informing it. If you don't know this information, just say you don't know. And then it will say, I don't know, if it's not confident enough. So these are a few of the model parameters you can tweak to, I guess, impact that hallucination area of things. So one of those is like the temperature. It's a numerical value between 0 and 1 that you can set to influence how creative the GPT model is. So a value of 0, a temperature value of 0 will give you a very deterministic answer. So if I say the same prompt over and over again, it will give me a very, very similar answer each time. But if I have that temperature set to something like 1 or 0.9 or 0.8, so the higher end of that spectrum, then that will give me a more creative answer. If I say the same prompt multiple times, it will probably give me, it will most likely give me a very different answer each time. Same thing with like the top probabilities, setting the top P to 1 or 0 influences how creative the response will be. And you can also set other parameters too, like the maximum number of tokens, because as we said, a token represents words. So, having larger prompts with larger responses will consume more tokens. And if you're using like Azure OpenAI, where the costs directly relate to the amount of tokens you consume, then you might want to look at setting a max tokens to ensure that you're not consuming like thousands and thousands of tokens per request. And there are a few other things like penalties, which are further detailed in the API regarding tweaking. Fine-tuning, so the idea of customizing OpenAI models using external data sets, right? So, if you had your own data that you wanted to fine-tune this GPT model on, that is something which you can do using Azure OpenAI. So this is really involved with retraining a new GPT model over a domain of data. And the benefit of that is, you get really higher quality results, lower latency requests. But one of the cons is that it is computationally expensive compared to just using the out-of-the-box model that's already sort of like provided. And so there are ways around how you might train a model on your own data without having to fine-tune your own GPT like model, right? And these are some of those considerations before you look to fine-tune your own model. So, looking at this sort of hierarchy, no context, just being you don't fine-tune at all, and you just provide prompts to the model to give you back the responses. And then there's this notion, the next level up, the notion of prompt engineering, right? So the idea of giving the GPT model what it needs in terms of that prompt in order to reply back with a more specific answer. So it doesn't necessarily involve fine-tuning your own model, but let's say you wanted it to answer some data on this 3-page PDF document that you have. You might pass this 3-page PDF document to the GPT model and say, answer me questions based on this 3-page document. And the way you engineer that initial prompt to answer those questions based on the document is known as prompt engineering, and we'll see that in the demonstration. Next level up is the concept of few-shot learning. So you're actually giving a few examples in your prompt in order to better give a response. So if you wanted to summarize a document in a specific manner, you might give an example of how you want that summarization to look like. Hey, here's a summarization I want to make from the document, put in your own summarization, and then say, can you summarize the rest of the document for me like this? So that's something like few-shot learning. It's giving multiple little examples of what you expect to see, and then being able to learn and give a response based on that, right? And then you have things like the prompt context. So it's like prompt engineering, but you're also giving the actual data in of itself. So something that I was saying before. So you're giving the data as well as the prompt, and then finally fine-tuning the model, so retraining the model on your own data itself. There's also the concept of content filtering. So when we use the AI model, we want to be sure to detect any misuse. So this is something which is also built into Azure OpenAI service. So if someone says a prompt that is deemed having something like self-harm or violence, then the content filtering system will pick that up and it'll block that response essentially. So that is something which we've built and it actually works quite well. A few sample use cases, so extracting information from text and summarizing it. So having a customer conversation, for example, and then I have an Azure OpenAI service instruction, which is essentially the prompt, extract the following from the conversation, 1, main reason, 2, the sentiment, and that responds back with the output. So you might want to use it for a scenario of like summarization, right? This one is more around generating text via different languages and whatnot. So the instruction is in English, the output is in English. And in this scenario, this is a call center automation prompt. So it's turning sort of unstructured data into structured data. So it's taking this information and it's actually generating a JSON response, right? So you might, get this JSON response and incorporate it downstream into your applications. So if I wanted to visualize some of this data, or perform further analytics on the data, it might make sense to structurize this data. And so that's what we've done in this sort of sample use case here. It's creating structured data from unstructured data, right? And so one of the, I know I'm just about on half an hour, so I'm almost finished the concepts, and then we'll get to the demo sort of side of things. So what you're seeing here is an architecture which achieves adding your own data into OpenAI. And so I won't spend that long on this, but this is essentially what I'll be showing in that demonstration. So essentially you have something like your document library. So let's say it's a storage like folder, and it just contains 100, let's say, like PDF documents which you want to be able to search over and interrogate. So you might pass those documents to something like a document chunking function, which might take all these single like PDF files, split them by page, extract the titles out of each of like the pages and the sections within each of these like pages, to be able to be indexed into something like Azure Cognitive Search, which is essentially an Azure service that provides search capabilities over indexed information. So why we extract the sections and the titles is to really provide OpenAI with that semantic level understanding. So if I wanted to search within a specific section within a document, it is aware that that like section exists, right? So let's say an appendix. I want to ask a question about the appendix of a certain document. It doesn't know that that is the appendix if we haven't extracted the title and the sections in the pages to say that, hey, this is the title, this is the appendix. So we go through a document chunking slash document cracking process to get those initial PDFs and to break them down into those individual titles and sections and individual like pages, and we index them. So once that's indexed, the OpenAI app will pull those necessary indexes. So if I say what is the top 3 cars that were produced in 2021, then that's going to specifically be about cars, right? I'm not going to pull all 100 PDF documents into the OpenAI service and say search all of these, because that might not be theoretically possible. That might be too large for the API to even handle. We want to be able to only give it the section of data that it needs. So in other words, the N relevant sections, we want to be able to only extract the relevant sections which relate to cars in this example, right? So it's only going to extract those sections from those documents which relate to cars, and that's going to append all that information regarding cars with the initial prompt to the Azure OpenAI service to essentially give you your answer. And then once it gives you your answer, it's going to return that to the user application, which is then returned back to the bot or whatever they're using. So that's how we're applying ChatGPT over your own like data without necessarily needing to fine tune and host your own GPT model, right? And yeah, you'll see some of that in the demonstration. Lastly, and we're getting to the end of my presentation slides, but this is sort of 3 Azure certifications which I encourage for the purpose of upskilling, and as part of the Microsoft Student Accelerator program. This is 3 which I would personally recommend that relates to the content which we've covered, and that's more around sort of Azure AI like fundamentals, so that's like a fundamental AI exam. Then we have our Azure AI engineer, which is like the step up from the AI like fundamentals. And then we have our Azure data scientist exam. So these are three which I definitely recommend and encourage. And it's always good to start with the fundamentals exam if you haven't yet achieved that one.
They already have the OpenAI, ChatGPT, and DALL-E content in the Azure AI Fundamentals Learning Path now.
Oh, there you go. Yeah, we're very, very quick to add that.
I don't know whether it's in the exam yet. I did ask one of the girls who's just done it recently if they saw it, but she didn't answer me yet. But yeah, it's definitely in the learning path.
I need to renew mine in that note.
Not fundamentals; those never expire.
Ah, good point. There you go. Even more motivation to obtain yours if you haven't already.
Yeah.
So this is quick demonstration time. What I've done, I'm sure some of people, if you're viewing this call from MSA, would have seen the bot service in some way, shape, or form. So this is what I've done. I've simply just started this demonstration by following this example Learn document to create a bot with the bot framework SDK. So the very, very simple bot, all that it really does is it echoes what's back, like to the user, hello and welcome. If I say hello, it will just echo that back to me. So it's a very simple bot. And just a word of note, this is not related to OpenAI, ChatGPT. This is purely Azure bot service. So if you want to host your own bot on Azure, this is the service which you would probably be looking at. So that's what I've gone and done. I've gone ahead and I've taken this bot and I've cloned the repository, spun that up in my environment, and I've integrated that myself with Azure OpenAI service. So what I've done, just to show you what the end output looks like. Run this app. Okay, that's running. So this is the final output of what I've built. So if I go restart conversation, essentially what this is an Azure bot, and all this is doing is it's taking my input, going to Azure OpenAI, using my input to call the Azure OpenAI service and returning whatever output is received from Azure OpenAI's ChatGPT back to my own local Azure bot. So it's really using this as middleware software, if you will, in order to talk to the bot. And so what I've done is essentially just integrated it that way. So if I say summarize quantum computing in 2 sentences, that's going to give me back the summary of quantum computing. If I say something like, what is the next number in this sequence? 2, 5. Fibonacci sequence, for those that have seen it. So it's saying the next number in the sequence 21. So it's actually realized that this is the Fibonacci sequence, which is pretty cool. Yeah, that's pretty much the bot that I've made. And so how this works is I've taken that bot, that simple echo bot, and I've quite literally just integrated Azure OpenAI, right? So as is the case in the bot source code, these are a few of the Python libraries which I've imported. So this is really around the bot builder as a service. So this is how these are other libraries to interact with the Azure Bot Service, otherwise known as the Azure Bot Framework. Then I'm importing, the Azure OpenAI library to be able to talk to Azure OpenAI, and a few other libraries like Azure Key Vault and Azure Identity. So these are more concerned with authorization and authentication. So what I've done is I've now I specify the name of a key vault, and what Azure Key Vault is it's essentially a service to store like your passwords and your secrets and your keys without necessarily exposing them in your application. So when I go to specify my OpenAI key, I'm not directly inserting the key in my code. What I'm doing is I'm storing the key to my OpenAI to be able to use the service in my Azure Key Vault, and then I'm essentially just authenticating to the Azure Key Vault and retrieving that secret on the fly. So this is the best practice in terms of actually that security of how do you obtain that key for authorizing via those APIs. So this is where the chunk of the bot logic is contained. So I've really just taken that Echo bot and I've done a very simple modification of a simple API called OpenAI. So this is where, and as I say, my comment, this is an example. This is also very bad design, what I did here. And I'll tell you, one reason why this is very bad design. But essentially what I've done is I define the API call here. This is my response. So I'm using the OpenAI library. This is a chat completion because I'm using the Chat GPT service as opposed to just a regular completion. So then I'm specifying the engine, so Chat GPT, and this is where I define the messages and the prompt of the API call. So there are two main facets here. So the system message is your opportunity to tell the bot how to react, tell the bot how to operate. And in this example, all I've done is I'm saying you are an AI assistant that helps people find information. Nothing more, nothing less. I can incorporate other things too here, like anything that I want. Be very specific with your answers. Don't give too much creativity in your responses. When a summarization is asked, please give them in numbered points instead of just regular dot points. So these are your opportunity to fine-tune how the bot responds to the user, and that's known as the system prompt, the system message. And then I have my own prompt that I give to the service. And so instead of hard coding my own prompt, I'm simply passing the prompt that the user will put in the chat of my bot into OpenAI. And so why this is really bad design, this works by the way, but why this is really bad design is because I'm passing user input straight into an API request without doing any validation or any error checking whatsoever. I'm not cleaning the data. So normally what you would do is you would clean inputs, you would strip away any malicious code, or just things that shouldn't be in an input, while this is just directly, quite literally copying and pasting everything that the user says into the chat directly to the API request, which is simple, but yeah, not the best practice here. So there are other things I can tweak too. So I spoke about the temperature. 0.7 is a fairly creative temperature. So this is saying I want you to be fairly creative, but not too creative. Otherwise, I'd set this to something like 1 or 0.9. And then now is max token. So, I specify 800 because, I can specify the maximum 2000, but this as this is hosted on Azure, this is going to consume my Azure credits. So I want to be sure that I'm keeping within those limits. Top P and frequency dependency, these are a few other parameters which I haven't really tweaked with, which do further, I guess, make some changes there. And then finally, what I do is I return that final message into the bot. So how this looks like without, returning this is something like this. So I can just copy that and say print response. So now let's restart this app and see what that looks like. All right, so that's loading. Should take a few. Yep, there it is. So now I can just say summarize. So this is essentially the response that I get from OpenAI. It's that's the response there, and so it's essentially this. We give them the created, the model, and that seems to have been stripped. Let me restart that. There should be more information there. Let me just try to redo that. Yep, so that should be right. Okay, let's try that again. Test. Okay, there you go. So what that's responding with is an array called like choices and the index, and inside the choices array is another array called message, and inside that array is where the actual content that I want to extract. So that's where this comes from. I'm going into that response. I'm selecting only the choices, and within those choices, I'm selecting the message, and within the message, I'm selecting the content. So I'm directly responding to the user purely based on what's in the content. I don't care about all the other like metadata, right? So that's what I'm doing here. And essentially what this like function is on message activity is it's saying that whenever a user sends a message to my bot, I want this to be executed. I want this function to be executed. So every time a user asks a message to the bot, it's just going to get that like user message, ask it to ChatGPT and return that response into my bot. And the last like function is on members added activity. That's the first like function that gets executed when a user launches a new Azure bot session. So that's just going to say hello and welcome to the Azure OpenAI service experience once the like session gets launched. So now that you've seen the code, let's do that exact same demo within the context this time. So I've started up my application. And while it's doing that, a quick note that, this is one way which I've actually developed this bot. I'm developing this bot like locally, and that's in my opinion an important thing to call out, because being able to fail fast when you're engineering something is really important. When I was trying to develop this, I didn't know this immediately. I didn't know that this is what I wanted to extract. I was just simply extracting the response, right? And that was giving me a lot of errors. Now imagine if I had this hosted in like a production like server. I would need to download the bot, make the change, republish the bot in order to see if my code is working. But instead, I'm actually running a local instance of this bot, which makes testing and it makes engineering easier. So thinking about how do you make changes to your code and see the output of the code as quick as possible is very important when you're developing, right? Because you don't want to have like 5 minutes in between that. Otherwise, the development process just takes really, really long. So being able to test like locally, being able to spin up a local instance, I feel is actually very important, and it made my development experience a lot easier. And I'm doing that through the bot framework emulator, right? So instead of having to redeploy and publish my bot into its endpoint and test if my new code is working, I'm just I'm launching a local instance of my bot and testing it that way. And then when I get the output that I like, oh, this is great. Then I will publish that to the internet. Michelle, you have your hand.
Yeah. What do you think about code spaces? Have you tried using that?
That is also a very, very good call out, and just one of our awesome innovations, right? So, you might want to limit your environment to a certain subset of tools. One of the things which we have in technology as a general is we have so many tools available to us and so many ways of doing the same one thing, and code spaces is an awesome thing to call out, Michelle, because like that is a single integrated platform to do a bunch of the development things. So it will host your virtual machine, it will host all the code tools that you need to develop, and all the open source libraries that are really popular, all the overhead that usually comes with developing a product or a code base of sorts. GitHub code spaces makes that really easy because it integrates directly with like a GitHub repository. So when you want to make a change to a repository, making those push and pulls is just like a click of a button. Very, very easy. Was there anything else you wanted to add on the code spaces front, Michelle?
Just point out that they can get 60 hours per month free using code spaces, so you don't have to pay for that. And also, yeah, I think one of the biggest problems I often have when I'm coding is the environment variables. I guess that it's different versions of different things and which ones are downloaded and all of that. Whereas with the code spaces, you can save a lot of time if you have a standard environment that you spin up each time and you want it to remain the same. So you can just use that one and everything's ready to go. You don't have to worry about the infrastructure anymore. You just spin it up in a minute and then start coding in the cloud.
Yep. And so that's essentially what I wanted to summarize, is that, there are multiple ways to skin a cat, right? And this is one way which I've done this, in one way which I've actually engineered this solution. And that's something which I'm a firm believer on, being able to test your code easily and efficiently will only benefit you. So thinking about how do you test in a sort of agile manner where you make a change, see that, and then you feed that back into the original loop. So was there a question from the audience?
I think it was someone inadvertently unmuted.
All good. So any questions on this? I have one more demonstration before I open up to questions. But any questions on this demonstration on how I've manipulated Azure Bot Service to integrate with Azure OpenAI? Any questions whatsoever?
Do you have that in a public repo that they can look at, or is that secret?
I do not, but I will be happy to host this in a public repository for sure. Yep, that's no problem.
I always like to look at the code. I need to stare at code a long time before I understand it. And in fact, now I have Copilot. I have Copilot chat, and I can ask it to explain the code to me if I don't understand it, which I love as well.
Yeah, very, very awesome application there. And I'll be happy to definitely host this. Something if there are no questions on that, this is what the Azure AI Studio playground looks like. So this is where we host our sort of Azure OpenAI like models. So this is also an opportunity for me to test before I start integrating in my applications. So I have a few deployments here. So I've deployed the GPT 3.5, which is essentially just the turbo model. 3.5 is essentially just ChatGPT. I've also deployed the 002 model, like a codex model. So I'm now free to experiment with these, change things like the temperatures, as I was saying before. So if I wanted to experiment with more deterministic responses, I might change the temperature on the right hand side here to something like 0. And I can just start asking questions as I would something like this. And so giving a higher temperature means that it's more likely to give a bit more creative-ish responses, or a different response rather than the same response. So if I were to put something in twice, so it's very unlikely with a temperature 1 that's going to increase the creativeness of the GPT model, but also increase the chances of hallucinations. So the idea of, as I was explaining before, the idea of generating new data that doesn't necessarily relate to the data that it's been trained on. So just generating garbage data, essentially. So one of the demos which I've also have, which related to the architecture, which I showed in the presentation earlier, is the whole idea of adding your own data into ChatGPT, and that's essentially what I've done here. What's portrayed in this sort of architecture. So the idea of having this sort of app server and orchestrator combines the query and the knowledge to Azure Cognitive Search, which will surface the data and return that back to Azure OpenAI. So if I were to show what that looks like, if I were to go into this sample repository, so I've went ahead and deployed this exact repository into my subscription. And it's something like this. So it deploys 5 resources: the app service, so that's the actual app that's hosting my code. The form recognizer, so as I was saying before, that's the tool that I use to crack down the documents. So I crack it down by the pages, and I crack it down by like individual titles and like sections, and that's indexed in the search service. So that's Azure Cognitive Search. So if I were to go into that and show you what that looks like, I can go into my indexes and click on this index. So this sample data is just trained on a fictional organization called Contoso about things like performance and employee sort of like information. So I can just say something like product manager in the query string, and this will return me those indexes from the initial data set. And so this will tell me which page it came from in the PDF document and the entire content in of itself. So this is all the content that was in that specific like section. Because as I said before, you don't want to, every time you make a call to OpenAI, you don't want to be appending all your PDFs into that API request. Otherwise, it just becomes too large, and you won't be able to fit all the data you have within that specific request. So you only want to include a subset of your initial the data, and that's what Azure Cognitive Search helps in doing. It's providing a subset of the data which relates to that initial search query. So that's Azure Cognitive Search. There's the app service plan, which is where the app service is like essentially being like hosted under. So this is essentially like the compute that you buy. That's the compute, while the first app service is really just the actual app instance. And while the storage account simply hosts those like PDFs, the initial like PDF documents, or it doesn't have to be like PDFs, it can be really anything. But in this example, we've put a bunch of like PDF documents. And so the final app is essentially this. It's a user interface that I can now interact with. So if I say what happens in a performance review, the first query always takes a few seconds longer than the rest. So that's going to essentially take the data and summarize it. So I can click on a citation here. It's also like referenced which exact page in which document it like referred to. So I can click on the citation and see, okay, this is the PDF document. This is the page within the PDF document, which it's like referencing. I can also see the supporting content. So, these are the indexes that are returned from that cognitive search index, which you just saw. So, the name of the file and that specific like section, which relates to the initial prompt. I can increase this. So in my developer settings, I can say like, let's say I wanted to, return 5 instead of 3. I can now change that to 5. And then now the next call, the amount of supporting content will actually be 5 now. So it will know more in order to form that final answer. And finally, the thought process. So, this is the key words that it extracted from my initial initial prompt. This was the actual prompt in of itself. So as I was saying before, the system prompt. This is like the system prompt. So this is an assistant which helps the company employees with their healthcare plan questions and questions about the employee handbook. And I'm asking it to be brief in the answers. Answer only with the facts listed in the list of sources below. So I'm saying don't go to the outside internet. Don't use any other information which you're aware of. I only want you to answer the prompt purely based on the sources which I've extracted from the cognitive search index. So that's what I'm saying in my system prompt. So if I say something else completely different, what is the stock price of Microsoft? So ideally this should, yeah, I'm sorry, I don't know. I don't have access to real-time stock market information. That's the exact sort of behavior which I expected, and that's purely because what I have in the system prompt. I'm only asking it to answer questions that's based on like the sources. And so if you wanted to see the source code that sort of like powers this, it's in that same repository which I've adapted this sort of like demonstration from. So I can go into my app and then go into my front end and then source, and then I can go into, I believe it's the API, not the API, and it will be the backend. Approaches, and yeah, so this is the approach which I'm showing, so the chat approach. This specific approach. There's also the ask a question approach, which you can select 3 sub approaches with, but that's a demonstration for another time. This is specifically chat. And so I can go ahead and look at how they've actually constructed this prompt. So, this is that exact same prompt that you just saw. And this is where they inject like the sources that was from cognitive search. And we also actually include the chat history. So, if I wanted to refer back to like a previous answer and say something like, can you please summarize that exact same thing, but with less sentences? It needs to have the context to be able to know that. So that's where I include chat history. And yeah, you can look at exactly how they formulate those API calls, the temperatures they've used, and how they construct that prompt. So that relates to that prompt engineering sort of concept, which I was covering earlier. So I'm exactly at time. That's essentially what I wanted to show you for today's session. I hope you have found that interesting. And yeah, this was recorded, so if you did miss a few of the earlier concepts, feel free to review the recording.